To help understand the common problem solving patterns in greedy algorithms, we're going to start with the activity selection problem. So, in activity selection problem, imagine that you are attending a conference and there are multiple talks that are happening throughout the day. And now you want to make sure that you attend the maximum number of talks without overlapping times, and each talk has a specific start and end time, and you can only be at one talk at a time, and that is the activity selection problem. And so a scenario here would be, we have these five talks. So we have the first talk here, talk one, we have talk two, three, four, and five. And as you can see, all of these talks have different starting times and different ending times. Now we want to make sure that we attend the maximum number of talks without overlapping the time, and we can only attend one talk at a time. So after having these talks, from the look of how the starting and end times are, how can you attend the most talks possible? So the greedy approach here would be, let's start with the greedy approach. So the greedy approach here is approach. The greedy approach is to always pick the talk that ends the earliest. So pick the talk that ends the earliest. And this way, you have enough room for future talks. It should be a T here. So this way, we have enough room for any of the future talks that we want to attend. So the step by step process here would be, we start by picking the talk that finishes the earliest. And in this case, it's going to be this talk one. So this is the talk that ends the earliest, which starts from 9 a.m. and ends at 10 a.m. And after talk one, the next available talk that doesn't overlap is talk three. So if you come to talk three, is the one that starts at exactly 10 a.m., which is the time that the first talk ends. And then after this talk three, we have talk four. Talk four starts at 10 a.m., which is the time that talk three ends. So this is going to be our next option. Our next option is going to be talk four. And finally, the other talk that we can attend in this case is talk five, which ends at 12 p.m. And in this case, we're able to attend a maximum, or rather, I'm able to attend four talks without any overlapping times. And that is now what we have here: talk one, talk three, talk four, and talk five. Now, why this case is going to work is because by selecting talks that finish the earliest, we are able to maximize the time left in the day for any of the additional talks that are there. In this way, we ensure that we attend the most number of non-overlapping talks possible. Right? So again, the greedy approach here is to make sure that we pick the talk that ends the earliest. Then from there, it allows us to start looking at the other talks. And that is basically the greedy approach, and that is how the activity selection problem works in greedy algorithm. Just to reiterate on the problem again, the problem is you are attending a conference. So imagine you are attending a conference here, and there are multiple number of talks happening a day. It could be more than five, from what I've written here. And we want to make sure that we attend the maximum number of talks without overlapping the times. And each talk has a specific starting time and a specific ending time. And yeah, that is it about activity selection problem. So next we're going to be looking at the fraction or knapsack problem.